We are going to discuss about gas laws. First one, Boyle's law. അതിനു മുമ്പേ നിങ്ങൾക്ക് അറിയേണ്ടത് what are the different variables related to gases. First one, pressure, represents letter P, temperature T, and volume V. Then first law, Boyle's law. According to Boyle's law, the pressure of a fixed amount of a gas is inversely proportional to volume at a constant temperature. That is, at constant temperature, the pressure of a fixed amount of a gas is inversely proportional to volume. That is, P proportional to 1 by V, then P is equal to K into 1 by V, then PV is found to be a constant, K constant. Okay, then according to Boyle's law, P1 V1 is equal to P2 V2 at constant temperature. Then how can you represent Boyle's law graphically? That is, a graph is plotted from pressure against volume. Then the variation of graph is like this. This graph is PV graph. Then P1 by V graph, that is directly proportional. Then PV P graph. Here we know that according to Boyle's law, PV is found to be a constant. So PV P graph, PV is found to be a constant. Here these three graphs are plotted from pressure against volume, pressure against 1 by V, then PV against P at constant temperature. So this graph is called isotherm. The graphical representation of or a graph is plotted from any two variables. Here pressure and volume, pressure and 1 by V, PV and P at constant temperature. This graph is called isotherm. Okay, constant temperature. This graph is isotherm. Okay. The next one, Charles law. Then according to Charles law, at constant pressure, the volume of a fixed amount of a gas is directly proportional to temperature. That is, V directly proportional to T. Then V is equal to K into T. Then V by T is found to be constant. If V1 and V2 are the volumes of two gases having the temperature T1 and T2 at constant pressure, then according to Charles law, V1 by T1 is equal to V2 by T2. Then how can you represent Charles law graphically? Simple. A graph is plotted from volume against temperature at constant pressure. So graph is like this. This graph is called isobar. Then this graph is not extended backward, not meet at a point 0, but extended backward, it meet at a point, that is meet at a point, then volume becomes 0. This temperature is called minus 273.15 degrees Celsius or 0 Kelvin. This is called absolute zero. Absolute zero means a graph is plotted from volume against temperature, then the particular temperature in which the volume of a fixed amount of a gas become 0. This is absolute zero. Okay. Then next, what is Gay-Lussac's law? Next one, third one, Gay-Lussac's law. According to Gay-Lussac's law, at constant volume, the pressure of a fixed amount of a gas is directly proportional to temperature. That is, P proportional to T. Then if P is equal to K into T, that is P by T is found to be constant. Then it is mathematically expressed as P1 by T1 is equal to P2 by T2. Then graphical representation of Gay-Lussac's law like this: P against T. Then graph is plotted at constant volume. So this graph is called isochore. Okay. The next one, very familiar with this Avogadro's law. In first chapter, that is in basic concepts of chemistry, already discussed Avogadro's law. What is Avogadro's law? Equal volume of all gases contains equal number of moles at constant temperature and pressure. Here temperature and pressures are constant, so V directly proportional to N, then V is equal to K into N, that is V by N is found to be constant. Graphical representation like this. Okay, clear? The next part, then what is ideal gas equation? Ideal gas equation. Simple. Ideal gas equation means, according to Boyle's law, V proportional to 1 by P. Clear? Then according to Charles law, V proportional to T. Then according to Avogadro's law, V proportional to N. Then combining these three gas laws, combine V proportional to 1 by P, proportional to T, then proportional to N, that is V proportional to N T by P, that is V is equal to N R T by P, that is PV is equal to nRT. This equation is called ideal gas equation, where R is a constant. R means here R, universal gas constant. Universal gas constant. Here P pressure, V volume, N number of moles, R universal gas constant, T temperature. Then what are the values of R? Values of R. First 0.0821 liter atmosphere, mole raised to -1, Kelvin raised to -1. Then 0.0831 liter bar, Kelvin raised to -1, mole raised to -1, or 8.314 Pascal meter cube, Kelvin raised to -1, mole raised to -1, or 8.314 joule, Kelvin raised to -1, mole raised to -1. So these are the values of R in different units. Here unit liter atmosphere, mole raised to -1, Kelvin raised to -1, liter bar, Kelvin raised to -1, mole raised to -1, Pascal meter cube, Kelvin raised to -1. Clear? Then the gas which obey ideal gas equation is called ideal gas. Ideal gas does not obey ideal gas equation is called real gas. Real gas. Clear? This is something about gas laws. Thank you.